everybody. So we have a lot of people here at the rec, and then we also have a lot of people joining from the remote from home. And we wanted to welcome everybody to our workshop today. We have a prototyping workshop with David and Raj, and I know they have so much information to cover to teach us all how to use the 3D printers and what we can use the 3D printers for. And so I'm not going to talk anymore. I will pass it on to David and Raj, and thank you for being here.
Oh, thank you. Hi, everyone. I'm Raj. Welcome.
I'm Dave.
And yeah, we're here to help you today to learn about 3D printing and prototyping. So I am a student founder here at the Rec Innovation Lab, and my company, Off-Grid Technologies, we're creating portable generators that take the power of a stream or a river and use it to charge your phone. So over the past couple of years, I've learned a lot about 3D printing. This technology is perfect for my prototyping because the charger is just about the size of a water bottle. It fits perfectly in this 3D printer, and this technology is absolutely awesome. So today in this workshop, Dave is going to talk to you a little bit about 3D printing in general, and then I'm going to walk you through finding a file, setting it up using the Rex 3D printer, and we're actually going to print a part live during this workshop. So within this 45 minutes, we're going to have a physical part. I'll show you how you can find that part, and we're going to actually make it. Then I'm going to pass it back to Dave, and Dave will tell you a little bit more about 3D printing while the part is going away, and then we'll look at the finished product. So without further ado, I will pass it off to Dave.
Okay, so I'm Dave, and I'm a student founder here at the Rec. I have a company, Palladium 3D, and as Raj mentioned, we're going to teach you how to use the printer today. Raj is going to do a live demonstration, and then I'm going to talk to you a little bit about 3D printing, the industry, how 3D printing is done, prototyping, and things like that. Raj has a great company called Off-Grid Technologies that he just introduced. I have a company called Palladium 3D, which is a prototyping company for that prints 3D prototypes for architects, designers, and entrepreneurs like yourself. And we're going to talk a little bit about 3D printing and give you just a little bit of an overview about it so that you can kind of understand, have at least a frame of reference. It's obviously too big of a scope to go into in one 45-minute workshop, but we're definitely going to try and cover some bases. So basically, 3D printing is a subset of what's called additive manufacturing. There's three main types of manufacturing. There's formative manufacturing, which is when you make something using a mold. There's subtractive manufacturing, which is used when you carve something out of something larger, like when you carve a baseball bat out of a block of wood. And then there's additive manufacturing, which is where you start with a material and you build it up with layers. All 3D printing is part of the additive manufacturing section of manufacturing. So that's why you may hear it referred to as additive manufacturing or 3D printing. 3D printing has become very innovative. It reaches all industries from food to manufacturing to houses and residential, the residential space. It's been on the rise in recent years, and it did $12.6 billion in 2020. It's a trend that's here to stay. Half of engineering businesses have already started to use the 3D printing technology, and more are on the way. And that the 3D printing industry is expected to double within just 5 years. It's popular because the technology is more accessible and affordable than it ever has been before. And so consumers are able to reach out and actually touch this technology. It's less expensive to buy many 3D printers than it is to buy a new cell phone. So you're going to see more and more of those coming available. And so learning the technology and understanding how it works is going to help you immensely as entrepreneurs. Additionally, a lot of 3D printing, although it deals in plastics, a lot of the plastics are reusable, recyclable, and there are a lot of biomaterials that are being developed right now to be used as filament in 3D printing. So it also can be eco-friendly. So at the same time as we're using it to produce and change the face of manufacturing, it's also environmentally friendly. So we're going to talk a little bit about prototyping, and you might know a little bit about it, but prototyping is basically when you create a model of an object so you can study it and make changes. Different progressive versions of a prototype are called iterations. Each time you create a new version of an object and modify it, you create a new iteration of that item. To give you a little bit of a model, Retraction Footwear launched a custom flip-flop in 2020. It used 3D printing to create the flip-flop, but it was able to do multiple iterations of the shoe and develop it. Here you can see in red is the original design, and here in black is the current design. In 1 year, they were able to create all of the prototypes to get from A to B and refine their shoe. In the old days, that's not something that you would have been able to do with traditional manufacturing prototyping. It would have been expensive, it would have been time consuming. And at the small business level, and these are small business people, at the small business level, it's not something that most of us would have reached to be able to do in terms of prototyping. We might be able to get one prototype made, if even that. Other than that, we would be stuck in some of the old traditional ways of prototyping, like layering cardboard, and I'm familiar with that. Or even at the top, you can see the prototyping for the Macintosh. It started literally with a block of wood, and it went from there. So whereas there was the old prototyping, in the old days, it was time consuming and expensive. Now 3D printing can be used to create a digital model that can be sent to a 3D printer, printed out, and viewed in a short amount of time. This allows an accurate model of a prototype to be creative. Then changes can be made to your digital model and a new iteration generated in short order to study those changes. In this way, 3D prototyping process allows you to draft, study, and refine a product idea well before you get to market. But what else can you do with a prototype model? Well, prototypes can also be used to show an idea to potential investors and raise money. They can be used in focus group studies, and they can be used to photograph for marketing campaigns. So today, prototypes are easier to generate thanks to 3D printing. But what does that look like? How do you get there? What does the process of using 3D technology actually really look like? The 3D process workflow looks something like this, and we're going to get into it later on in the workshop. You decide on a 3D printing technology, which we're going to explain. Select or create a digital 3D model. You modify that digital model using the printer's software. You send that digital file to the printer for execution using the printer software, and then you post-process the object after the print is completed. There's three main types of 3D printing, and we'll get to those later in the workshop, but I just want to expose you to them. There's FDM, which is filament based. It's called fused deposition modeling, and that's the kind of printer that we have here at the REC. There's stereolithography, which is known as SLA, and that's a resin-based printing, which we'll talk about later. And there's SLS, which is selective laser sintering, and that's a powder-based technology. So we'll talk about all three of those later on in the workshop. Right now, Raj is going to create a toothpaste recycler using the printer from the REC lab. So I'm going to turn this over to Raj, and he's going to talk to you and show you a little bit about setting up the printer, using the software to access the printer and to generate a prototype. And he's going to actually start printing one for us. And then throughout the rest of the workshop, we'll check back in with him periodically just to see the progress and how our piece is printing up. Okay, Raj? Turn it over to you.
I'm Raj. Thank you so much, Dave. That was a great introduction to 3D printing. So this is Thingiverse, and Thingiverse is a repository of 3D printed files. So these are things that people have already created, and they're models that you can use in order to 3D print. So all of these different things that I'm scrolling through here, you can 3D print any of these. So sandpaper storage, drain cleaners, these are all things that have already been designed by other people. So, you know, they always say, like, why reinvent the wheel, right? If they already have something designed, why reinvent it? Thingiverse has an awesome search feature, and you can look through there. There are also other websites. Thingiverse is not the only one. I would say Thingiverse is the main one for 3D printing, but just to show you, there is something called Cults. And so Cults has other 3D printed models. This is another website similar to Thingiverse. There's also GrabCAD. GrabCAD has, again, other models. What I will show you today is a couple of things that I have found on Thingiverse, and I just wanted to show you a couple of key features of how you would navigate this. If you are thinking, I might want to 3D print something, where do I find it? I would say that Thingiverse is the first place that you should turn. So using the search feature, I found this. It's a Mandalorian helmet. I think it's pretty awesome. And so somebody designed this, and this is like realistic that this could be, you see the print size here is actually quite large. You could realistically 3D print this and get it so it fits on your head. One of my friends has actually done this. I think it's pretty awesome. And so let's say I wanted to print this. How would I go about doing that? Well, first, I would look at the summary, just kind of read what they have to say. So this is whoever designed it. They wrote out this thing of whatever they wanted to say. They're saying it's a work in progress, and Thingiverse makes it pretty clear up here. It's a work in progress. So that's okay. We can still print it. And you would go to the thing files and click here. And these are all the files that the person who designed the Mandalorian helmet has uploaded to Thingiverse. And so in order to print this, you need to download all of the STL files. Those are the files that the 3D printer uses. And so all of these STL ones, that one, that one, that one, and that one, looks like this person has 4 pieces to their helmet. So if you wanted to print this, that's what you'd use. I'm just mentioning this because a lot of people get confused. They download the IGS file and it just doesn't work. That's not something that the 3D printer can understand. So the 3D printer understands STL files. So that would take probably about a day and a half to print. We don't have a day and a half today. So I'm gonna print something else. And this is what Dave showed before, this toothpaste refiller. So the idea behind this thing is if you have a travel size toothpaste, right? Those things are expensive and you have to go to the store and buy them. They're also kind of wasteful, right? But you have lots of those big toothpastes. So the idea behind this is you could get this little yellow thing, right? Screw it in between the 2 toothpastes. And when you're out of the small travel size, you can use your big one to refill the travel size and then you're good to go. So instead of buying a new travel size toothpaste every time you go traveling, you can use this 3D printed part to refill it. So this is what we're going to print today. I'm going to show you a whole steps of how to do it. So same thing, I'm going to go to the thing files. This is everything that the person has uploaded to Thingiverse. I have Colgate toothpaste here today, so I'm going to use the one that couples a Colgate toothpaste to a Colgate toothpaste. If I had another brand, I would download something else. So here we go. Downloaded the STL, and now I'm going to enter the MakerBot print software. So this is the software that communicates with this MakerBot printer. And what I do is I import the file. So I start at the top corner, import, add models, and I'm going to look for the STL in my file folder. So here it is, Colgate to Colgate STL file. So it is importing, and there it is. It looks very small because compared to the size of this, it is pretty small. I'll zoom in a bit. So this is the little part that we're going to print, this little thing. And so in order to print this, what we're going to do is we're going to slice it. And so Dave will explain to you how this slicing works, what it's doing. But this is, you're going to click up here. Let's see. Click there. So it's currently preparing the print. And what this is doing is it's slicing up the 3D printable part into something that the 3D printer can understand. So it's taking this little model and making it into instructions for the 3D printer of how am I going to move the nozzle around in order to make this thing. And so it's actually slicing it into thin layers that the printer prints one layer at a time and builds up and up and up on itself. So yeah, so basically this is going to go ahead and slice. It looks like it's taking its time today. And then once it is done slicing, you will, all I will do is just go over here and click the big print button in the bottom corner. And looks like you can't see that on the screen. Let's see. So you go over there, you click the big print button in the corner, and that's all that you would do to print it. So I will complete this. I'm going to get this started, and everyone who's in person, you'll see this thing whirring away. I will, for now though, pass it back off to Dave. He's going to continue talking while I get this print started. Dave will come back and check on me when this has got started a bit. So I will see you all soon, and back off to Dave.
So we're going to talk right now about the three main types of 3D printing. There's actually about a dozen different categories under additive manufacturing and or 7 different categories and about 12 different kinds of 3D printing. And they're working on new types of 3D printing all the time that I'll cover at the very end of the workshop. But we're going to cover the most 3 common types of 3D printing. And as I mentioned, that's FDM, SLA, and SLS. FDM is the most popular. 64% of the desktop computer users out there are using FDM filament 3D printing. So that's what we're going to mostly focus on today. And we're also going to focus on that because that's the kind of printer that the rec has. So that's what Raj is demonstrating on. So we're going to look at FDM. So FDM is the first of the 3 technologies. FDM is basically filament based. A filament gets fed into the printer like Raj explained, and then it gets printed out in layers. The FDM printers build the parts by melting and extruding the filament, and then it gets deposited layer by layer in a gradual building up process. And off on the left side of the screen over here, you can see an example of what a finished part looks like that's been built using the FDM technology and the filament technology. It tends to have, you can see little fine layers here. And sometimes you can do some improvements to reduce those layers or even post-process and finish them completely so you don't see them. But this is a very typical example of what you will get as a finished FDM part. The second technology we're going to talk about really quickly right now is called SLA. SLA is stereolithography. It's a resin-based technology, and it basically is a vat of resin that resides down here in the base of the printer. And what happens is a laser hits the resin, and where it hits the resin, it hardens the resin at a particular resolution point. And what you get with SLA is a more finished look like this here on the left. You can see this little castle figure. And then it's more finished, but the technology is a little bit different than FDM and the third technology, which is SLS. And it has its own sort of issues, and we'll talk about those also in a little bit. The third type of printing technology that we're going to talk about is SLS. SLS is selective laser sintering, and it's basically like the resin process, but it's powder-based instead of liquid-based. So basically here in the bed of the printer is deposited a big bed of powder, almost like really fine sand or a little bigger than dust. And then where the laser hits the powder, it hardens the powder. And this is an example of a part that you get once it's finished with SLS printing. It usually has a little bit of grain to it, like a gritty finish, almost like you would expect to see from a sandcastle. And there are ways of post-processing that part as well, so that you can reduce that effect. But this is what an SLS finished part looks like here on the left. Here's a comparison of all 3 of the different types of all 3 of the different types of printing. And so again, the filament, the resin, and the powder, FDM, SLA, SLS. When you talk about these technologies, you'll commonly talk about them using their initials. And so you'll be comfortable using those initials and discussing them in that way with other people that are talking about the technology. And again, in this comparison, you can see the layered effect here of the FDM. You can see the smooth effect here with the resin-based. And you can see a little bit of pebbly effect here on the powder-based, the SLS technology. So again, the 3 main types of 3D printing technologies are going to be FDM, which is filament-based, SLA, which is resin-based, and SLS, which is powder-based. And FDM, of course, is the most popular. After you print a finished part, you post-process it. There are lots of different ways to post-process parts, and that depends on which one of the 3 technologies you're using. But typically with these parts, and we'll talk about this in a little bit, there are supports that need to be removed. You can see some support structures here. These linear lines are support structures. We'll talk about those in a few minutes. If you're using the resin-based, you would have to wash it. This is a washing process for the resin part, and then you have to cure it under UV light. And here a part is being cured under the light. So these are additional parts of the technology that are required with the resin. You do get that nice smooth finish, but there's more steps to it. On the left over here, you can see the FDM, the filament technology. This is what this owl is what the part looks like once it comes off the printer. And with post-processing, you can get a more finished look to it, like the owl on the left. So you can do that with vapor smoothing. There are ways of sanding it, and a lot of these parts may get colored or painted or dyed afterwards. Additionally, there's some comparisons with the different ways that these technologies work. And so I'll just compare them for you really quickly. In addition to the post-processing steps, you can see that 3D printing is referred to as additive manufacturing because you're adding to instead of taking away in order to create a final object. And although through the three descriptions, you can see how some of the different technologies create objects through the building up of the layers. The important thing to understand about 3D printing is that there are many roads to get to Rome. So while each one of the three technologies uses an additive layering process to achieve its final result, each one gets there by a different route, has different considerations, and produces somewhat different outcomes. There are also varying post-processing steps to consider with each one of the technologies. The technology path you choose in step one will generally be determined by the use and needs of your finished prototype. As a quick snapshot, we can compare our three technologies. In one instance, a low resolution setting on an FDM extrusion printer will allow you to iterate more quickly and print faster, but may not have a very finished appearance, right? So you'll see those lines. You can increase that resolution as your prototype reaches a final stage to get a more finished appearance, but increasing the resolution will increase the build or print time. So it will take longer for that part to come off the printer. This may be useful for process step iteration, but a presentation-worthy prototype may require additional post-processing to achieve a finished look, make it look nice. In contrast to the FDM, a resin SLA printer will give you a much more finished look, but it requires the additional post-processing steps like rinsing and curing that take additional time to achieve a final piece. Though there are extra production steps in SLA, SLA is a popular technology if you have a lot of very fine detail or need to achieve a very finished look to your object. The third technology, SLS, which is powder-based, can be used to provide parts with exceptional durability. And although the powder acts as its own support system to support the part while it's being built, saving support, and that saves support removal time in post-processing, additional post-processing steps may be required with this technology as well. There are extra considerations that I will cover in my later workshop on 3D printing technology, which will really get into some of the finer detail of this stuff. But hopefully for now, this overview will get your gears working and kind of your thinking caps on about maybe the three different types of technology and maybe which one might work best for a prototype that you have in mind. Of course, you can always do an additional search or reach out to me or Raj if you have questions. But let's take a minute now and check in with Raj to see how our print is coming along. Raj, how's our print going?
Yeah, so it's going pretty well. So the print has gotten started. It looks like it's now 25% of the way done. And so what it had to do first is it had to heat up the extruder to 215 degrees Celsius. And it says that the chamber is at 26 degrees Celsius. So when it started, it was just at room temperature. So it got it hot, and now you might be able to see it on the camera over here. The printer is going away and printing the part. So there is a camera feed on the screen, but because we're just getting started, you can't quite see it. So Dave will come and check in with me again. And when you check in with me the next time, you'll be able to see it more clearly. There will be more of the part printed. So we're getting there, 25% of the way done. All right, back to Dave.
Okay, so now we're going to talk a little bit about the 3D printing workflow, and that's something that Raj just walked you through, right? So let's see if I can get the PowerPoint to run for me. So earlier, few minutes ago, we touched on the 3D process workflow that had the 5 steps. And then we looked at the 3 main types of 3D printing technology, the FDM, the SLA, and the SLS. But how do we harness that technology to work for us? What does that digital process look like? Our next steps involve working with a digital 3D model. We will look at that process. And again, that's the process that Raj has just demonstrated for you using Thingiverse and the MakerBot interface software. And then we'll dive again into the digital side of things. The first thing that so we're going to talk about selecting and creating a digital 3D model, modifying the model, sending the digital file to the printer for execution, and post-processing the object after print completion. Again, we talked about the three main types of 3D printing. I'm going to keep repeating this so that you guys can get it drilled into your head. FDM, which is filament, SLA, which is resin-based, and SLS, which is powder-based. Most popular, FDM. That's the one you're going to see out there in the marketplace most of the time. So the first thing I want to point out is that there are 3D print service bureaus out there that will take your digital file, optimize it, and print it. Many of them have incorporated quote software, so you can upload your digital file and get an immediate quote on the cost of printing based on options you select, such as size, material, and color. So once you have a digital 3D model file, if you don't have access to a printer or don't want to print the object out yourself, these service bureaus can do it for you. Of course, they're going to charge you for that, and there will be a price. How do you create or find a digital file to generate your print from? So there's several ways of creating a digital 3D file, and creating one from scratch and building it in modeling software is a much more involved subject for another workshop. You can create a mold from software. You can scan an existing item into a file modeling program. And you can even take two-dimensional pictures to generate a 3D model. And again, I'll cover these topics in more detail in a later workshop, but I just want to expose you to the options right now so that, to get your brains working a little bit. You can also download an existing file and modify it in software, as Raj demonstrated earlier. And luckily, as Raj showed us, there are lots of digital 3D files out there that have already been created. In fact, I don't know if you can see it, but I'm sharing. I printed something last night. I had a problem with my printer. I needed a solution. I downloaded a file. I printed the solution out on the printer, and then it worked for me. So that's kind of like the whole process of using 3D printers. You can individualize a solution. You can get it done right then and there, and then you can move forward with your situation. 3D printing is really a solution. So once you've selected a digital file and downloaded it, you open it in what's called 3D modeling software, a 3D modeling software program. There's two major kinds of software programs. There's modeling software, and then there's printing software. So in the modeling software, you open your file and you can manipulate it. You can change its size, its color, its attributes. You can make it dimensional. You can make it bigger, smaller, thinner, fatter. You can add if you want to put arms on the Lego brick, you can put arms on the Lego brick. You can do all kinds of stuff. All that happens in the modeling software. It's a little complex to learn that kind of software. And so it's most likely you'll be dealing with somebody else that's more familiar that you meet or know that knows that software. But you can certainly take some classes and learn the software. And some software is a little bit simpler to use than other software. You can edit virtually every facet of your digital object using the digital modeling software. My goal is to help you understand that process and not the actual software itself. You can take entire courses to learn that. But in truth, you'll probably work with someone else that's more familiar with the software. But essentially digital modeling software is what you use to create, modify, and finalize your digital model before you move on to the actual printing process. Once you have that digital file completed, you'll save it and you'll open it in a 3D printing software program, which is also called slicing software. Most 3D printer manufacturers have their own software that is typically optimized for their machine. There are some third-party software programs out there like Cura or Simplify 3D and Octoprint that can be used to translate the digital modeling file into a file that can be read by the 3D printer. With this software, you can make modifications to your file related to the printing of that file. You can scale it up, you can view your model from different positions, and you can customize the printer settings to fine-tune the printing of that file. So essentially in the modeling software, what you're doing is you're affecting the actual appearance of the model. In the 3D printing software, what you're doing is you're affecting how that model is going to print on the printer. Will it be bigger, smaller? Sometimes you can add colors to it depending on the type of filament that you're printing in. So the 3D printing software is what's generally attached to the computer. These are what the interface, some of the interfaces look like. You can see they usually have an orthographic box like this. You load the file in, it will appear here. Oops, it will appear in that box. And then you can modify it, play with it a little bit, and then send it to the printer for printing. These are examples of the kinds of settings you'll look at when you're working with the typical 3D printing software. On the right, there's a lot of different settings in here. There's tabs, settings. It can be kind of daunting. There's a lot of things to learn. Some of this is experiential. It's okay. If you're a novice to 3D printing, most 3D printing programs have something like an interface option like over here on the left, where you just say, I want the resolution low, I want it standard, I want it high, I want a brim, which is a little rim that you print so that makes it the 3D object easier to pull off the platform. And then when you select one of these, all these settings will modify automatically. So you don't have to know every single one of these right off the bat. Over time, if you do printing, if you get used to the printers and you experiment, you may want to go in and customize some of these settings. You might want to say, I don't want my base print speed at 60 millimeters a second. I want it to print slowly so that I don't get any loose threads. I'm going to set it at 40 millimeters a second. But I want to increase my travel speed to 100 millimeters a second. So that will preserve your speed time. So you can change all these settings later. But what's important to you to know right now is that most of these software programs have sort of novice settings over here. And you can usually choose between the novice or the advanced settings. That's in the 3D printing software. A couple other things I just want to touch base on with you about the 3D printing software. When you print a 3D object, this is the model of our object here. We've opened it in our printing software. As you know, the printer prints in layers, right? So what happens when it prints over here across empty space? Well, that resin is just going to drop right down because of gravity, right? So, oops, go back. So they have these things in 3D printing called supports. They're overhang supports. And there are different types. There are 4 or 5 or 6 different types I've seen that get used. This is called a tree-like support. And what happens is as the printer is printing this object from the bottom up, it also prints these little support objects. So as you can see, when it gets up here, when the filament gets to that layer and it starts to print across here, it has a support to print across so that it doesn't just fall right down onto the build plate. These are linear supports. Often in the 3D printing software, you have the option to delete or add supports as you wish. So if you think maybe these are too many supports, I don't need that many. If you have that experience and you want to say, I want to take some out, you can click some of the supports and just hit delete. So that's sort of how supports work and what they'll look like in your 3D printing program. After you've got your print set in the 3D printing program, you're going to slice it. You're going to hit slice. And what the printer does is it then takes whatever the final appearance of your 3D object is, and it turns it into this stuff called G-code. And G-code generates basically an XY axis. Let's see if I have a slide of that. I do. It generates this XYZ axis, which is how the printer works. It goes forwards, it goes sideways, and it goes up and down. It generates a point. Every one of these lines of code is a point. And it tells the printer, lay filament at that point or don't lay filament at that point, or lay filament at that point a little thicker or a little thinner. It generates lots of this G code. And then that's how the printer knows what to do with its different layers here. Does it print thinner? Does it print thicker? So that's what the G code does that gets generated behind the scenes in this modeling program. The G code is basically what machines like CNC machines and other types of manufacturing machines and 3D printers use. That's the language that they speak that tells them do this at a particular point in time. So it's called G code, and you'll hear that terminology when you're dealing with 3D printing. When you're generating your model and you're playing with layer height, these are just some examples of how the layer height changes. Maybe you want to do a draft model, so you choose something like 0.8 millimeter layer height, and this is going to print much faster than this higher resolution model, which could print 3 or 4 times as slowly. But you see the difference between the thick layers and the thinner layers. And so depending on where you're at in your prototyping process and what you want to do with that model, you may just want to print it out real quick in like an hour or two and just see what it looks like with something that you've added to it. You could do that in a draft mode like this with a lower resolution. Then you might want to print it in final version in a high resolution. That might take a long time, could take a day, could take a day and a half, depending on how large your object is, if it's like a football helmet or the size of a basketball. But you're going to get a much more finished look to your object by choosing the higher resolution. So this slide just gives you a little bit of an example of what those layer setting comparisons are going to look like. Again, you'll get more familiar with this once you start actually using the program. I just want to expose you to these concepts generally. And this is basically how a 3D printer works. The filament comes in, it extrudes down, and in the X, Y, Z axis, it tells the printer where to lay the filament down like this, and it builds it up layer by layer by layer by layer. That's pretty much how the printing works in FDM technology. It's very simple. After we print, we do our post-processing. And so there's, like we talked about, there's different kinds of post-processing. There's vapor smoothing, there's rinsing and UV curing for SLA, there's powder removal. I don't have a slide for that because you're basically just vacuuming up powder, so it's not very interesting. But then there's dyeing and painting, and there's a dozen or so different ways to post-process your part to finish it after the printing process. So what I want you to understand is that once it comes off the printer, it's not really the complete process yet. There is still some post-processing to do to that part. And then FDM and SLA will have different supports that you may have to remove. And we talked about the support structures, and so you have to pull those off once the part is done printing. SLS will have extra powder, and so that obviously needs to be vacuumed up. It needs to be brushed away from the part. The nice thing about these technologies is that in the resin and in the powder-based technologies, and even to a certain extent the FDM technologies, these materials are recyclable and they're reusable. So if you have a vat of resin and you're printing using the SLA laser technology, the leftover resin can just be dumped back into the container and then reused. I mean, it's kind of a gross comparison, but it's like reusing French fry grease. You just keep using the grease until it's no good to use anymore. So it's nice because that makes it less expensive. You don't have to be constantly buying the material. And you can reuse the material, and a lot of these materials are recycled. Some of them are chemical based, they have to be disposed of properly, but even like the thermoplastics that are used in the FDM technology over here, a lot of those can be melted back down, and there are actually little machines you can buy, and you can pour the little pieces of broken filament in there. It'll melt it down and it will extrude it back into filament again. So you can reuse that material. And that's just really kind of like a great environmental part of this process, because even though it's technology and we're creating all this production, this manufacturing, and creating all this stuff out of plastic, it's really comforting to know that we can reuse that stuff. It isn't just, we're not just adding junk to landfills. We actually can reuse those materials. So it's sustainable as well. And now we're going to check in with Raj to see if there's been any progress in our 3D print.
Okay, yeah, we do. So it looks like it's 95% done now. So we are like almost there. So if you give just like probably a couple more minutes and then check back in, Dave, we will be there. So so yeah, it's pretty much there. Those of you who are in person, you can look on this camera over here where I'm waving my hand. You should be able to see like a yellow little part coming up. Yeah, you can see it. Yes. So how many millimeters? That's a great question. Yeah, so Dave went over like the different print settings. And so you'll be able to see this like and touch it in person. So for this one, I use a 0.2 millimeter layer height. And I didn't use any supports on this. It doesn't need it because this is just gonna build straight up. What I'll show you though, is I think this is kind of interesting. What Dave was showing of how the printer builds up. This is what was sliced for this part. So you'll see that it's kind of building up. And that's the part that we're printing. So these are the instructions in the G code for this little toothpaste screw job. And so this is exactly the process that Dave described is just what we did at the beginning of the workshop here. So I will pass it back to Dave. It looks like we are almost there, 98%.
So basically, Moore's law tells us that the power of computing can be expected to double every 2 years. And like computers, in 10 years, 3D printers have gone from very expensive multi-component machines to desktop printers that can be purchased for a couple of $100s. There we go. So this is an example of 20 years ago what these SLS technology looked like. And this is an example of where it's come today. So in another 10 or 20 years, how small and how effective and efficient is this technology going to get? 3D printing has infiltrated lots of areas of manufacturing today, and it's upended the traditional production method. 3D printers are capable of off-the-shelf product quality for objects as varied as metal machine parts to pliable customized shoes. One of the most attractive parts of 3D printing is its ability to individualize an object. So instead of being forced into printing thousands of the exact same item, each object can be tailored and unique. 3D printing also allows products to be created on the fly as long as you have a printer, software, and materials. So a Navy destroyer at sea can print a mechanical part they may need to make a repair on without having to return to port for a layover. And a running shoe can be customized to a wearer's foot to match their unique needs. Products can be customized with names or even printed with barcodes or QR codes hidden inside the product itself. And these codes can be scanned to provide ownership information or a link to the most current version of a user manual, or even bring you to a website where you can order replacement products. So as you can see, there's a lot of different things that can be done with the 3D technology. There are some applications of 3D printing I'm going to run over real fast because it's pretty cool where 3D printing is being used today. So here's an example of.
Hey Dave, it looks like we have to wrap up really soon. Do you mind? The printer just finished. Do you mind if I jump in and show the finished product? I'll just show the part and then we can wrap it up. How about
I think
that?
that's probably the best. Yeah, that's probably the best.
Okay, sounds great. So this is it. It did finish. All right. So can everyone still hear me when I'm here?
So yeah.
Is that right? Okay. Yeah. So this is the part, showing it to this camera and everyone who's here. This is it. The little toothpaste part. I'm going to take it off the print bed. So this is it, and I'll show this all like closer to you guys. I'll pass this around when I'm done. So for now, I'll show this to the camera. So this is the part. There is a little raft on the bottom. This helped it to stay on the printer. So I'm just gonna peel that off. So now there's no more raft. So it's nice and easy. Yeah, it just helps it stick to the printer. So this is it. I'm going to test it out. So I did conveniently bring 2 tubes of toothpaste here today. And this one is an empty travel toothpaste, and this is a full big toothpaste. So let's see if it works. A wrap and a brim are similar. A brim just goes on the outside. So like a brim version of this wouldn't have a center. It would just, it would be like just on the outside. The wrap goes all the way around. That's the difference between the two. So I'm gonna screw this in to the small toothpaste, and I'll screw it into the big one, and that should be, then we should be able to transfer it.
Cool.
Yeah. Hey, Dave, while I'm doing this, do you want to wrap up the workshop, just conclude your part of the presentation, and then we'll end it with the toothpaste transferring? How about that?
Good idea.
So I'm just going to quickly run through these to show you some of the applications for 3D printing. They can be used to customize shoes to a wearer's unique. They can be used for medical models, prosthesis. They have great dental applications. They're 3D printing food now, desserts, pastas. It's being used in jewelry. Actually, Ukraine actually won the Basel Art Award for 3D printing this last year. And that's the ring that they submitted and won on. Even like a 3D printed USB drive out of gold. It's being used in fashion and in shoes.
This
That
is
the
this is the big
final?
deal. So yeah, so aside from all those other like cooler applications. There's the toothpaste. We're still here. This is printed in the last half an hour. And as you can see, I will fill this thing up. And there you go. Look at that. Now the smaller toothpaste is full. So we can use that smaller toothpaste. Yeah, so that's what it is. So thank you all so much. I'll come over here just to wrap this up. So thank you all so much for coming to this 3D printing workshop. We really appreciate it. Dave gave a great overview of the different types of printing technology, the process of how you're going to prototype. And I think that this is a resource that's available to all of our students here at the Rec. So I hope that this gives you enough to kind of get started, and you should be able to now like go to Thingiverse, download the files, and print something on this printer. So I hope that this gives you enough and you can see the potential of 3D printing. So we will probably have a follow-up workshop to this because we didn't get finished today, but thank you so much for coming and we will see you soon.
All right. Thank you so much, everyone.
Thanks, guys.